Hello, good morning to all of you. So, to our viewers, to all the students and teachers who are watching our channel. So, this time we are going to discuss the board examination solutions for dryer problems. We have started like days ago. We tackle one problem about the dryer, and this is just the continuation. So, dryer board exam solutions. Before we go to the problems, let us review first about the dryers, now dryer fundamentals and dryer formulas. So here is the basis for the ideal dryer, adiabatic. Adiabatic means there is no heat transfer, meaning there's no heat in or there's no heat out, meaning that the heat cannot go out or cannot comes in, not so adiabatic dryer. So the schematic is like this. We have here at point one, somewhere in point one, there's a heater. There's a heater, and then after that there is a fan, and after the fan there's this the dryer. So point two is the fan, and three is the dryer output or discharge. No, so here in the heater, there's a lot of media here or method. You can use steam. You can also use electric dryer, but others are using steam. So we have a mass of steam and enthalpy of steam. Here, because it's outside, there's a mass sub A, MA, mass of dry air going to the heater, and here there is the HFS, and then here there is this dry bulb 1, then wet bulb 1, and relative humidity 1 at point 1. So here is the heater, and of course if you have a heater there is a coil. Yeah? So the coil, the heating coil is here. If you are, yeah, the heat, yeah. So heating the heater coil is here, and if you are using steam, of course the steam is the one flowing into this tube, no, if you are using steam. Then here at point 2 is the location of the fan, and it will fan out air into this dryer. So this is the dryer, adiabatic dryer. So if this is dry bulb 1, so this is dry bulb 2, no, dry bulb 2. If this mass of A, mass sub A, so this mass sub A, because mass is just uh, constant, no? So if it enters here, so there is this mass flow of air coming into the adiabatic dryer. And then when the dryer has already done its part or function. So here is the discharge at the point 3. So here we have mass A again, then dry bulb 3, relative humidity 3. Okay, now going back to the dryer, there is something else that is happening here, and it's about the feed and the product, because the dryer is just like a vessel, like a vessel that you have an input and then you have an output. But on the inside there is something happening now. You are trying to put here some materials. Now you are trying to feed some materials like maybe grains or palay or sand or copra or coconut coir or textile, whatever you want to dry, you have to do to load inside the dryer, and that is in general called feed. Yeah, so you are feeding a material, so in this direction, and then when it comes out, it is coming out as a product. So there are two sections here. One is feed and the other one is product. So here in the feed there is a moisture uh, of feed, percent mm, percent moisture of the feed, and here is the percent moisture of the product. So from here we can infer, we can deduce, no? We can say that the moisture content at the feed is more compared to the moisture content at the product side, right? Because moisture content is, or the water vapor content is being extracted or released, and then it will become dry, or drier, more dry than the condition in the feed, no? So this schematic diagram helps us to at least imagine what is happening in the dryer. So these are the concerned parameters, no? And there are considerations in the dryer. So there are fundamental considerations, and these are as follows. Unless otherwise specified, drying operation is always adiabatic saturation. Now, so adiabatic saturation wherein wet bulb is constant, no? So adiabatic saturation. So in the psychrometric chart, no, psychrometric chart. So this is the psychrometric chart, no? So this one is heating, this one is cooling, sensible heating, sensible cooling. Then this one is humidifying, no? This one is humidifying, the other one is dehumidifying. Now, in between, there are some processes that is involved. Now, where's this adiabatic saturation? So, adiabatic saturation is here now. So, there's a you can project a line going like this, and then it is the adiabatic saturation where wet bulb is constant. So, all the wet bulb temperature here is constant. Okay. So now, the dryer capacity is always referred to the product unless otherwise specified. So the capacity of the dryer cannot be measured in the feed, no, because nothing is happening, no, nothing drying is happening here, no. So the capacity is always at this side, no, at the product side, meaning after the dryer accomplish its function. Now, the dryer and product relationship is the one that is always being asked in many problems. For example, in the board exam, they always ask for dryer feed and product relationship. So we will discuss a bit later what is the relationship between the product and the feed, or feed and the product. Then another question is always being asked is the capacity of the fan in the dryer, meaning the capacity in terms of what meter cube per hour, liter per hour or meter cube per hour. So that can be found if you can locate the specific volume of the fan, no, in the psychrometric chart also. Then the required heat of or steam flow input of the dryer. So what amount of heat is required to dry a material at this relative humidity or at this moisture content or percent moisture. So that amount of heat is always being asked in the board exam, because this is the uh, review or practice in the board exam. So here, feed or product. As I told you, there are uh, two sections in the dryer, and let me use this portion here. So here is the feed. When you try to have a feed, then you will have an output as the product, and each material, I mean the material in each section has a percent moisture. So here at the product, there's a percent moisture, which is obviously lesser than the percent moisture in the feed. No? So the dry, I mean the dryness, or let us say the temperature of the feed should be lesser than the product. Yeah? So when after the dryer, it should be hotter, yeah, than the initial. When you try to first put the materials in the dryer, So it is not as hot as when it is coming out, right? Now, what is the general equation for the feed or the product that serves as a governing equation in the solving of problems in the field of air dryer? So here we have the principle of mass. And what kind of mass? The bone dry mass. So bone dry mass by principle in dryer is constant, meaning the mass that is coming in is the mass coming out. So how do we put that here? Bone dry mass of feed, so meaning the mass of the feed equals mass of the product. No, but what kind of mass? It is bone dry. Bone dry. Yeah, bone dry of feed is bone dry of the product. Now, the general formula is this. Now, F, so F is quantity 1 minus percent MF equals P 1 minus percent M sub P. So what is F? F is mass flow rate, meaning the material that you are trying to feed or to put in the dryer can be measured in terms of kilogram because it's a rate mass flow rate. It could be kilogram per second or kilogram per hour, right? So those are the units. So and then if you are going to multiply with 1 minus percent MF, so it's just a number, no? So for example, 1 minus zero point 0.5 or zero point 0.9, so still it becomes the the kilogram per hour, no? So it will this unit will prepare. Same thing with the product. So the product has the unit of kilogram per minute or per hour or per second. So it is a mass over the time. Yeah, it's a rate of flow. So kilogram per hour, right? So times 1 minus percent MP, and then you will get the bone dry mass with respect to the product because on the left is the feed and on the right is the product, right? So that is our general equation, and on the subsequent or the following pages we are going to dissect, we are going to put into details or maybe so much detail about the equation. How did we arrive in the equation? So here is the derivation. No? Which derivation? This general formula here. Where did we get this? Now, so it's better for us to understand where is this derived or where is this coming from. That the of course it comes from the bone dry mass of feed equals bone dry mass of the product. Yeah. So here is the derivation, and we're going to discuss this, right? So here is the feed now. So there is this component of the feed. Yeah, feed. Now, so here is the mass flow of feed, and then this is the bone dry mass of a feed. Now, mass of feed and bone dry mass of feed. That is the section wherein the feed is kind of decomposed into. Yeah. So I have here the whole feed. I have here the mass flow of feed, and I have here the bone dry mass of feed. Now, this is the mass flow. This is the mass flow, and this is the bone dry mass of feed, no, BDM, right? So here, what about the feed? The feed is the total, yeah. So when we talk about feed, so it is the same as this. So MT total, yeah, total mass. The total mass that we are talking about is the mass flow of the feed and then the bone dry mass of the feed. So if we are going to put that into equation and do some kind of manipulation, so our feed is the empty, right? So this one is the total mass. So MF, this one, so MF plus bone dry mass of feed equals F. Now F, but F is equals empty, right? F is feed equals total mass. So it's just this equation. So here is the mass flow, that one, plus bone dry mass of feed equals the feed here, right? So here is just the summation of this element and this element, right? So I think it's very clear, you know. So the total mass is the feed, then mass flow rate of the feed plus bone dry mass of the feed. So if we continue on the development of the equation, so percent MF, so how do we get the percent M? There's another equation given here, and it says percent MF. So how do we get the percent MF? So meaning percent of the mass flow is equal to MF over F, right? So MF over F, that is the percent. Now it's like this, yeah. So so this is the portion, the mass flow, and then this the total, right? You the feed, or the this one, or the total mass. So if you get this, you will of course getting a smaller number. I mean a decimal number. So it is termed as percent MF, no? Percent MF of the feed. So meaning it's the percent moisture of the feed. So let me continue in this so that we can systematically tackle this topic. So percent MF, right, are here. This one, MF, the percent MF equals F minus BDM. What is F minus BDM? F minus BDM. This one, now from this equation, you can get the equation of MF here. Yeah. So MF here. So how do we get the MF here? Mass flow of feed equals, just transposing this now, equals F minus BDM. So what I did is just I put this on the other side, right? So MF equals F minus BDM. So we can um, uh, substitute this here. So F minus BDM, what is F minus BDM? F minus F minus BDM equals F sub M sub F, right? So that is M sub F. We just expand F minus BDM, and this one is percent MF over F. So we just expound this into this kind of expression. So when we have this expression of percent MF, we just have to cross multiply now. So we cross multiply this and this, we cross multiply this and this. The denominator is only one. So it will retain now F minus BDM. This one is F times percent MF. Yeah, so percent MF times F. This one. Okay. So now we have this equation of percent MF times F, then F minus BDM. As you can see, what could we do? What do we do with this? So we can try to transpose and then rearrange if there are, or if there is common factors. So how do we rearrange and manipulate this equation? Let me use another yeah uh, color so that it will be more clear to us. So we're here, right? We're here. So again, we are trying to get the bone dry mass. So if we are targeting here, all we have to do is to transpose this on the left, and then F will remain, and then this on the right, right? So let me put that in this, right? So percent MF times F equals F minus BDM. Our interest is this BDM, right? BDM. So I'm gonna transfer this to the other side of the equation. So what will happen is that this BDM, now I'll transfer it, then what remains is F equals F, right? And then everything else, F minus BDM, F minus percent MF. So what do we do next? So after this, BDM equals F, then minus, we have to transfer this now. So this, we have to transfer on this. So it will become minus. So F minus BDM, right? So BDM will be there, and then F minus percent MF. So this thing here is coming from here, right? So this whole thing here, we have to transfer there, and this negative BDM we have to transfer there. So it's like just an exchange of place. So now we will get the BDM F per minus percent MF, and then as you can see from this simple equation, there is a term that is common. I think you can see, all of you can see that, and that is the F, or the feed mass flow rate of the feed, you know, in kilogram per hour and kilogram per second. So if that is common, so we can say that here, no, so we can put it here, BDM equals what? F, right? That is the common. So in order to get the F, I have to multiply this by 1, and then to get this term, percent M, and then F. So I have to put that in minus, right? So minus percent MF. Okay, so this is because this is a common term, common for this and for this. F minus percent MF, that is BDM. So why is that relevant? So now, if I may rewrite, so BDM is F 1 minus percent MF. Okay, so going back, here is this, right? F, this one. Let me encircle this. So F 1 minus percent MF, meaning the mass flow of the feed is 1 minus percent of the so-called the moisture content. uh, Moisture content. So this is the feed, and this is the product. So same thing will happen in the product. It will become P, quality 1 minus percent MP, or the moisture content. No, because the moisture content is that is something that is you want to remove. Yeah, for example, zero point 0.2 or zero point 0.5, about 95%, 0.95 times the kilogram per hour, and that's gonna be equated here, or to put in the equilibrium. So there's a balance between this bone dry mass of the feed coming in and the bone dry mass of the product coming out, right? So same thing with the product. Let me discuss that. Even though we have discussed the feed, let me discuss the product. So the product is like this. Now, if we have a product, it is uh, going to be subdivided into two components, which is the MP, meaning the mass flow rate of the product, and the bone dry mass of the product, right? So that is the composition of the P, which is the product, meaning the product that is coming out at the discharge chute, or the discharge side of the dryer. Now, the product is also called the total mass. So this P is called the total mass. So it's a mass, but totality of mass in the product side. So if we if we are going to to equate P now, so P is like this now. I think it's lacking the subscript here. So P now, this is the P as a whole. P is the summation of M sub P and BDM sub P, right? So if we put that in the equation, P equals M sub P plus B dm sub P. Now, so there are two components of this product. So the one that we just um, discussed this, yeah, P equals M sub P, this one, and BDM, right? So here, MP plus BDM. Yeah, so is the mass and then the BDM. So we just put the subscript P, mass flow rate of the product plus bone dry mass of the product equals the product, yeah, coming out of the dryer. So by way of manipulation, you can get the percent moisture. Yeah. How do you get the percent moisture of the product? So percent moisture of the product is the mass flow rate of the product over the total, the product, yeah, the product total. So here, as what we have done or we did in the feed, so it's like this now. Percent MP is MP over P. Now, so for example, if we have this mass flow rate of the product as kilogram per hour, then the product here also is the kilogram per hour. Then it will be multiplied by 100. So this is just the fraction, meaning the mass flow rate of the product is the you divide this in totality with the product, which is bone, bone dry mass, the bone dry mass plus MP. Okay, so if you um, equate this, or if you get the ratio of this, the mass flow rate over the totality, then you will have a percent, percent MP, as can be seen here. Okay, so by cross multiplication, or cross multiplication will yield to the equation becoming like a linear. No, P percent MP equals MP. Are you following this? Can you follow this? Percent, this one, P, this P, just put it here, times percent MP equals MP. Yeah, so here. And then what can you do with this? We have to transpose this, right? So P percent equals MP, then P minus BDM, because we just have to expound some of the terms. So MP, MP, not percent MP, but M sub P, meaning the mass flow rate of the product, we can derive it here. No? So how do we derive it here? This one. So mass flow rate of the product equals P, this one, minus, we put this on the other side, minus B dm of P, bundle mass of the product. So here is the MP. So what is MP? P minus BDMP. So this one. So we have to substitute this. We have to substitute this. Yeah. P minus BDMP is this. Now P minus BDMP. So that is MP. You know, so this whole expression here, this whole expression here is just coming from here, which is MP, right? This one. MP is P minus BDM. So P BDM of P. So as you can see, we could get some common. Yeah. So what is the common term there? Let me change the color of the pen so that it will be more visible and more clear to us. So I think you see this, the common term here is the MP, right? This one and this one is common. So all we have to do is rearrange. So we have to rearrange here. I think, sorry, the common is P. Let me. Yeah, I'm a little bit confused. So P is the common, and here is the P, right? So all we have to do is this percent MP. What do we do with this percent MP? So first we factor out this. So let me put here. Yeah? So P percent MP equals P minus bone dry mass of P. So here the common is this, right? P and P. So that is the common there, yeah, P and P. So if we want to put that and get the BDM, because our interest is the definition of BDM, a bone dry mass of the product, because that is the critical parameters that we are trying to measure. So BDMP, so if we put that here on the other side, we will be left with P, and then here, this whole thing, P minus P, percent MP. And it's pretty obvious that the common is P. So we take out the common, 1 minus, this one is 1 also, percent MP. Okay? But 1% and percent, right? It's like uh, is not being put. Yeah, so what we will be left as an equation for us, let me put it here, is BDM, that is 1, BDM equals P, 1, this one, yeah, 1 minus percent MP. Okay, so let me write here. So it will be more clear. Bone dry, bone dry mass is P because there's a common P here, right? P from here, P minus P percent. So P minus quantity 1 minus percent MD. So percent MD. So this one, this equation here is also this one. So we were able to derive with the MP 1 minus percent MP. Okay. So I think that's very clear for now. Yeah. So here is the major equation. BDM P minus 1 minus percent MP, and then when you go to the feed, this one BDM, yeah, because BDM of the feed is equal to the BDM of the product. So in this case, BDM F 1 minus percent MF, yeah. So that is the moisture content of the feed and the product. So that is how it is being related, how they are becoming related. So there's another parameter that that is always being asked in terms of board exam, and that is the fan capacity. So fan capacity. So let me write here. The fan capacity is this. Yeah? So the volume flow rate at uh, at that point times the mass flow rate at that point, and then here if you're gonna check the units, so volume flow rate is what, kilometer cube per hour, right? Meter cube per hour, and then mass of air is also different. So mass of air is, let us say, kilogram, force per hour, right? Per hour, because it's a kilogram. Yeah, in the mass, and is the volume. So per hour, no, per hour, meter cube per hour, this the kilogram per hour. So both the r can cancel, meter cube per kilogram. So this is the meter cube per kilogram. So where V is the specific volume, and the m cube is kilogram, and then VA, volume flow rate in meter cube per second, and that MA is the mass flow rate. So those are the parameters to be solved, especially on the board exam problems. There are some notes to remember. before we proceed to the problem, M sub A. So M sub A is dry air, not humid air. When you talk about M sub A, it is based on the dry air, not the humid air. Because the if you get the mass of the humid air, so you have to add still the water vapor content in the air. So what we're talking about here, as far as M sub A is concerned, is based on dry, not the humid air. No? So the humid air as a component of water vapor. Then here it says on the number 2 bullet, the psychrometric chart shall not be used if the pressure is not atmospheric. So it is a common knowledge that all psychrometric chart is based on atmospheric pressure, meaning what is atmospheric pressure? So meaning it is 101.325 kilopascal, then 14.7 psi, 1 atmosphere, and so on. So it is based on the atmospheric condition. Yeah. So this one. So psychrometric chart is based on standard air. Yeah. Meaning 1 atmosphere. Then dry air is it the formula is this, right? So that you will kind of remember. So dry air is total air minus humid air. So if you have seen this, you will infer that the dry air can be found if you multiply the humid if you deduct the humid air from that. So there's a humid air, there's a total air, so total. Then you get the portion of this, yeah, minus humid, meaning like a moist. So total minus humid, so it will become full full of dry air. Okay, so dry air is total air minus humid air, and M sub A, again I'll repeat, for computation purposes, M sub A is, we are considering the dry air there, not the humid air. So another a tool that will help us in the solving of the material under drying is the material balance, of the dryer. Meaning, if you are going to put a box right here, so at this point, so mass of air is coming, then it's going out. No, mass flow of air. So that is the rate of air passing or coming into a certain structure. But here, in order to get the energy, yeah, so here we have the mass times specific humidity. So mass times specific humidity, how do we do that? So mass is in kilogram, specific humidity is where? So specific humidity is kilogram of water vapor over kilogram of dry air, kilogram of dry air. So if you have that, no, so if you have that, you can have the material balance, mass times specific humidity, now coming in. Then this one this one is mass times specific humidity also. No, it's H3. So this one is the feed. Now feed, when it goes down, it is the product, meaning it is less in moisture but high in temperature. So this again is the schematic diagram. Then first the air enters with the heater. So this is the point 1, and then at point 2 it is going to enter in the diagram already. So here is the point 2, right? So you can get the dry bulb 2, then the airflow NA, and then this adiabatic dryer, so that is the discharge, is you can term that as dry 3, or um, at point 3. Yeah? So this is the discharge or the output of the dryer. So you can find um, these parameters like the mass of air, then dry bulb 3, relative humidity 3, because you are in point 3. What can you say about this specific humidity? So specific humidity at point 1 and at point 2 is the same. No? So SH1, so specific humidity at 1. Okay. So SH1 times MA, so it will give you a heat, yeah. So because you can check the units, so here, what's that? The unit is kilogram per hour times. So here is this uh, specific humidity 1 equals specific humidity 2. Where is this happening now? So if you have a psychrometric chart like this, yeah. So normally you have this yeah, specific humidity 1. Then if you project that at constant temperature, meaning constant temperature. So because this is T, right? Temperature. So if temperature is constant, and then it will go here again. It will lower down the temperature and the pressure, and then you can go down here. So we can get some parameters by combining two. No, because this one is given specific humidity, then the other one is relative humidity, and the others are the the other properties. So to finally end the material balance happening in the dryer, so it is like this: mass in equals mass out. So mass of air, meaning the dry air, plus mass of air times specific humidity 2, plus F, the mass flow rate, equals MA, meaning the mass flow rate of air. Then this plus MA, meaning the, the heat, the mass flow. You have to multiply with the specific humidity, and you just add the product. So here on this side, because it's a mass balance, this is the product side, and this one is the specific humidity. Then so this the feed, and this the product side now. So put fan after the heater if not specified. So if there are problems wherein the location of the fan is not specified, you should put the fan after the heater. So we have here fan. So we have here the fan, and we put that uh, the fan after this one, right? So here is the heater, so we put the fan after the heater, and then it will fan again in the adiabatic the dryer. So this is just the reminder of how to manipulate the material balance. So put fan after the heater, and then there's equation here. HFG, meaning H sub F sub G, is a mixture of dryness and with the water vapor. So you can have the Hg minus Hf. So the formula, the general formula for this is like this, yeah. So HFG equals Hg minus Hf, but H, now the enthalpy is H at that point, and then plus X HFG. Okay? So, dito lang umiikot yung formula ng ganyan sa H plus X plus X HFG. So this X here is the quality of the steam, yeah, and it's also called dryness, fraction. So dryness fraction. So this is the formula for the material balance happening in the inside the dryer. So let me clear that. Okay. So here is the psychrometric chart based on SI units, and here is the psychrometric chart based on English. Yeah. So to review you on the psychrometric chart, first it is based on atmospheric pressure, meaning atmospheric condition, meaning 1 atmosphere or 101.325 kilopascal. Now, where is this enthalpy? Enthalpy is somewhere here. When the enthalpy, ano, so here is the the, the psychrometry for English, right? So here is the specific humidity, somewhere here, and then here is also the humidity ratio, which is the same. So this one here is the enthalpy BTU per pound of the dry air, BTU per pound of dry air. So this one, BTU per pound of dry air, and then the others is the relative humidity. Yeah, so this curve here, curve. Yeah, these are the relative humidity. Yeah, so relative humidity. I think this 60, 80, and then 100. No, it's 20 points graduation in the gradient. So 100, 80, 60, 50. Okay. So here in the process analysis on the heater itself, air side meaning the air that is being heated up, the air is being the air that is on the steam side. Now, so it should be that the heat of the dryer will balance this, the air side and the steam side, or the air side, for example, the one that's happening in the air, and also the steam, the one that's happening in the tube of that specific glass side. No? So this is the problem. We will, in a short while, we will take this up. So here are the problems for the dryers that are being considered in the board exam. So we have here board exam given last October 1981. So board exam of mechanical engineering about dryer, continuous dryer in 1981. Oh, long time ago. So if I may read the problem, a continuous dryer is supplied with air at 21 degrees centigrade dry bulb and 16 degree centigrade wet bulb, heated to 75 degree centigrade. It enters the heating coils at a velocity of 366 meter per minute, and the size of the circular duct is 183 centimeter. The condition of air leaving the dryer is 43 degrees centigrade dry bulb and 70% relative humidity. The moisture content of the entering material is 24 percent, while the moisture content of the leaving material is 8%. Now, the question, calculate the amount of moisture evaporated, meaning the amount of water content that is being extracted or evaporated is being asked. Then the capacity of the dryer, we know that the capacity of the dryer is based on the product or the output. Then heat supplied to the dryer. So what is the heat being supplied by the heater to the dryer? So what is our first approach or attack? No, how do we attack? How do we approach the problem so that we can solve this systematically? I think the best way to solve this is to draw the diagram and put all the necessary given the known data. What are the data available? So I think I have here on the slide here. So let us list down one by one the given, right? So we have here a heater that has 21 degrees dry bulb and 16 degrees wet bulb. So where's that? Here. So there's a dryer that has I mean in the point one, yeah. At the outside of the dryer there's a 21 degrees dry bulb and 16 degrees wet bulb. So as you know, this dry bulb is always higher than the wet bulb unless you are in the saturation point. Now, if you are in the saturation point, the dry bulb and the wet bulb is going to be equal or the same. Then it's heated to 75 degrees centigrade. No, meaning after the heater, it becomes 75 degrees centigrade. No? So let me show you where is that in the diagram or illustration. So here we have the dry bulb, wet bulb, and after the heater, it becomes 75 degrees centigrade now at point 2. So these parameters here are in point 1 before the heater. So there's a mass of air. So also there's a mass of air here. So the dry bulb after the heater is 75 degrees centigrade. I think we are clear on that. And let us continue on the problem. It enters the heating coils at a velocity of 366 meter per minute, and the size of the circular duct is 183 centimeter. So here, what is given is the velocity of the the air, not the velocity of the air that is entering the heating coil now with a amount of 366 meter per minute, and the size of the circular duct, meaning there's a ducting, 183 centimeter. The condition of the air leaving the dryer. So where is that? Leaving the dryer. Where is that? Leaving the dryer is what? Here, right? So here is the point 2 entering to the dryer, then leaving the dryer is this. So it has 43 dry bulb temperature, no? And 70 and what is this? 70% relative humidity. Okay, 70% relative humidity. Okay, so now let me use this so that we can decompose the component. So if this is the dryer, so entering the dryer after the heater, so this is the heater. So after the heater, the temperature is high. Now it's like a 75 degrees centigrade, but the air before entering the heater coil is 16 degrees centigrade. Now, after the dryer, it is expected that the temperature will a bit go down because you are trying to put or feed some material here. What is this material? Oh, it doesn't say anything about the material, what kind of material, but it will be put in the dryer, so this temperature will a bit go down, and what that is expected, and the temperature is 24. degrees centigrade. Okay, so now how many how many temperature points are we talking about in this problem? How many temperature points are we talking about in this problem? First, from the raw air, yeah, dry 16. Then after the heater, it becomes 75. Then after the dryer, after the material were dried, it becomes it becomes 24. Now, there's another thing that we are going to consider, and that is about the material. So the material in the drying process is called uh, feed and product, right? So meaning um, 75, 43. So here's sorry, 43, 43 degrees centigrade. Okay, I stand corrected. 43 degrees centigrade. Now, about the material. So meaning here there is this material that is coming in. Now, so we call that feed, and there's a material coming out. We call that as product. Yeah. So what do we know about feed? What do we know about feed? It says here the moisture content of the entering material is 24%. So here the percent M moisture, F moisture of the feed is what? 24%. While the moisture content of the leaving, expectedly, it should be less than that of 24 because it's already dried somehow. Now, some portion were dried, some of the water were evaporated. So here, the percent moisture of the product, percent MP, is how much? 8%. Okay. So here is the situation. Now, let me let me draw let me draw the psychrometric table in a very fundamental manner. How many points are we talking about here? The temperature of air, we have 16 degrees centigrade. Then we have, it is dried to 75. No? Okay, so from here, so here is the 16 degrees centigrade. This is the 75. No, so if you can see this, no, so this is a dry bulb, another dry bulb. This you can get a lot of things, right? Like this the enthalpy, the specific volume here, the enthalpy and the specific volume here and here. No, what can you say about the line that is going to from this point? Let us say this point one and this point is a straight line, meaning for every point that you have in this temperature, this is constant and this is W, no, one or W2 is the same, no, because it's straight line. So W means is SH, specific humidity. The other name for specific humidity is the humidity ratio. Okay, so humidity ratio. So the humidity ratio or the specific humidity is just the same, and the symbol being used in engineering, in mechanical engineering, is W. No, let us use the W for now. Yeah. So after one and two is the heater, then the dryer. No, so it goes back a bit lower. So meaning here, no, it goes back in a lower. lower form. So it is now becoming like 43, right? So 43, yeah, here 43. So there are 3 points, huh? 16 now before entering the heater. After the heater, it becomes 75. When you try to feed, try to put the material, that is 24%, and after the dryer or the drying process, it becomes 8%. So uh, some of the water vapor were extracted, or the water were evaporated. So it becomes uh, what is that? 43, right? 43. So 16, 75, and 43. So now we are going to take up. Yeah. So here, first we are going to get the points that is given, and then we will try to get the data from the psychrometric chart. Now, before we do that, let us be clear about what is being asked of us. Amount of moisture evaporated, meaning what is the amount of moisture in the material that is being fed, and then after it was dried, how many moisture, no? Amount of moisture evaporated. Amount of moisture evaporated. So how many moisture or water were or being evaporated in this case. Now the of course the unit there is also the flow, no, flow rate, mass flow rate. So let us say it is an kilogram per minute also, or kilogram per hour. Then capacity of the dryer. So the capacity of the dryer is normally in the product. So what is our unit? The capacity of the dryer is in kilowatts, no? Because it's heat. The capacity is in terms of heat, no? So kilowatt, yeah. Then heat supplied to the air, so it's also heat, no? So what is the heat supplied to the air so that it can evaporate that amount, or it can dry that kind of quality, wherein from 24% it becomes 8% uh, of the moisture, right? So first, let us focus here on this thing. Uh, what can we get from this value? First, 21 degrees centigrade and 16 degrees centigrade wet bulb. So meaning 21, then 16 degrees centigrade. Let me draw that so that so if this is our psychrometric chart, pardon me, I'm not yet good in this digital pad. So 16 and 21. Huh? So let us say that is 21. So 21 degrees centigrade, right? 21 degrees centigrade. If you get the 21 degrees centigrade dry bulb dB, then another parameter was given 16 degrees. Yeah. So this wet bulb is always lower than that of dry bulb. So you can have 16 degrees. Now, for example, let me use another yellow color, and that is yellow, so that you can differentiate the lines, no? So if this is the wet bulb in the dry bulb in 21, then the wet bulb is here, so here adiabatic saturation, yeah. So this line is wet bulb, and this is what is this? 16 degrees centigrade. This is 21 degrees centigrade. So the meeting point of 16 degrees centigrade and what is this? 21 degrees centigrade. Yeah, 21 degrees centigrade and 16 degree 16 degrees centigrade is this. No, from here you can get things. No, what is this? No, so here you can get things like you can get the enthalpy. Yeah, so here let me put the enthalpy later. No, so here 21 degrees centigrade and the other is in heater, no, because in a psychrometric chart, the line going to the rightward to the right is sensible heating, meaning there is happening here. There's a increase in temperature, sensible heating. No, so if we increase the temperature because it passes to the heater coils from 21, it becomes 75. So here it is just like straight. No, so let us say that this point is the 75 degrees centigrade. No? From 21, it becomes 75 degrees centigrade. No? So that is heating because it's heater, right? Heating, sensible heating. So here, what can you say about this process? The the straight line will tell us that there are constant or same values happening. No, the specific humidity one, this one, yeah. So one and specific humidity two is just the same, or SH1 equals SH2. Okay, so that is the uh, or one of the data that we can get. Yeah. So with this portion of psychrometric chart, we can also get the other parameters. Yeah, like this one. No. So the other parameters that we can get is the enthalpy, right? So if you know how to get the enthalpy, you can have that somewhere on this side, yeah, and then you can have this. Yeah, for example, this the enthalpy line, and this is the other enthalpy line. No, so you can say that this is H1 enthalpy one, and this is the H2 because this is the constant enthalpy lines, meaning all the enthalpies here are the same, all the enthalpies here are the same. Here, all the specific humidities are the same. Yeah, so we can also get other parameters if they are needed, like the specific volume. No, so in this case, we can get the specific volume if we want and if that is needed. Yeah. So we were able to locate this 21 degrees centigrade dry bulb, 16 degrees wet bulb. We can get the enthalpy one there. Then point two after the heater. This is point two is after after the point after the heater, or the end of the heater. That is the start of the heater is this in the A, the mass of air, and then it ends in the 2. Yeah. At point 3, 43 degrees dry bulb. So here, look at this. Yeah. So from 21, then it becomes 75, right? 75, and then it goes back to 43. So of course our drawing our drawing of the psychrometric table um, is not based on proper scale, but of course we could say that it should go back. No, the line should go back because it is lower than that of the the end of the heater. No, the end of the heater, the end of the heater is 75 right here. So this one, all right, the end of the heater is 75 degrees dry bulb. Then at the end of the dryer, the discharge of the dryer is 43. Yes, 20, 70. How do we do this? 20, 30, 40, 50, 60, 70, 75, no, 20, 30, 40, 43, no, somewhere here. So let us say here, yeah, 43. So I'll project, yeah, so let us project, yes, let us say here. Oh, not yet. We need another parameter, no? So 43. Of course, we know the temperature that is 43 degrees centigrade, but there's another point that we need so that we should locate the exact location, and that is the 70% relative humidity. So 70% relative humidity. Let me use another color so that we can differentiate everything. Yeah, right. So here, somewhere here is the middle. Yeah, at the middle, this curve. What is this curve? This is the relative humidity. Let us say 50% relative humidity. So we have to to get the 70, yeah, so 50, then 60, then 70. Now maybe somewhere here is the 70 and the 43, yeah, so 43 and 70, yeah, 43 then 70, okay, 43 vertical upward, then 70. So this line is 70% relative humidity. So you can have this point here as 3, right? So 1, start of the heater, 2, end of the heater or beginning of the dryer, then 2 to 3. So let me put this black line. So from 2 it travels to 3. Okay, from 2 it travels to 3. So this is the discharge of the dryer, the point 3, the discharge of the dryer with, what is this, 43, no? So let me put this, 43 degrees centigrade and 70% relative humidity. So that is how we uh, locate the points. Now, so now, what do we do with this? No? What do we do with this? We can get the data. So what is W1? W1 is also a specific humidity one. Now, meaning specific humidity one here. Now, so you project this from here going straight to here. So specific humidity 1 equals specific humidity 2, or W1 is W2. So what is this? 0.009, and the unit is in kilogram because we are in metric, right? So kilogram per kilogram. Kilogram of wet or water divided by the kilogram of dry air. So that's the meaning of specific humidity. So W1 from here is also W2, same. So W1 is W2, like this, right? So as you can see, this one and this one is the same, no? Because W1 is W2, or specific humidity 1 equals specific humidity 2. Okay, now from 1, this point, this point of 1, yeah, point 1, you can also get the specific volume, 0.846 meter cube per kilogram. You can also get the enthalpy, as I told you, this one, yeah, enthalpy 1, then specific volume, specific volume of 1, you can get. So this one is the specific volume, this one is the enthalpy, right? So specific volume. Now, and then 2, when you go to the 2, what is this? The point 2, you can get the specific volume at point 2, you can get the enthalpy at point 2. So this one, now enthalpy at point 2, then specific volume, let us say here, right? Maybe we can project a line, yeah, like that. So a specific volume at point 2. Okay? Now, What about 3? The 3, you can get the specific humidity at 3. Yeah, so let me use another space. Yeah, so here, so that we are clear on this. So here is the psychrometric chart, right? So here is the 21. We were able to locate because we have another wet bulb temperature, which is 16 degrees centigrade, 21 degrees. Then we could get from here the enthalpy and specific volume, right? So we were able to get the enthalpy one, then the specific volume, no, of one. Then here, it is heated up to 75, right? 75 degrees centigrade. No, so here the specific humidity one is equal to specific humidity two, or the W one equals W two. Then here, after this, so after this, no, you can get the specific humidity one and two. Then the dry bulb 75, and we're good on that. Now, and then it after the operation of the dryer, this is the heater. Then the dryer, after you feed, it will go down a bit. Now from 75, it becomes what? 43. Yeah. So 43. From here, of course, this one at the point 2, you can get the H2, right? H2. That's why we have H2 here, right? And then here at point 3, you can get the W3 here. Okay? So W3, which is the specific humidity 3. Okay. Now there are other things that are given here. The velocity of the air going inside the tube of the heater is 366 meter per minute, and also there was a given duct, meaning circular duct. There's a circular duct because this is a square duct, yeah, or trapezoidal duct. Here is the circular, right? Circular duct. The diameter is 183. Yeah, diameter is 183 centimeter. Let me go back to the problem. 180. Yeah, right. So the size of the circular duct is 183, meaning the diameter. Okay. So now, how do we solve the problem? The problem is amount of moisture evaporated, and what is our formula? Yeah, here. So the amount of moisture evaporated or extracted, the amount of water is extracted, is here. No, mass of the dry air, MA, then specific humidity 3 minus specific humidity 2, no, which is also specific humidity 1, right? So if we rewrite it, mass of air, so that is mass of air, then that is W3 minus W2. Yeah. So it's like this, right? So what is our mass of air? Mass of dry air. Do we have mass of dry air? No, yes or no? So mass of dry air, as of now, we don't have, right? But this is located at point 1, right? So at point 1, we can get the mass of dry air because we have a formula. Uh, because we have a formula here. So mass of dry air is what? This is specific. What is this? Volume flow rate, right? So mass of dry air, meaning Mass of dry air is like kilogram per hour or kilogram per minute. It's just the volume flow rate. Now, volume flow rate in kilogram per minute. Then this is specific. Uh, this one is what is this? V 0.846 meter cube per kilogram. That is the specific volume at that point. Yeah, this one, right? V1. Okay. So V, no, that is the volume flow rate. Then this is the V at 1. Now, so here we can have this, right? So how do we get this volume? How do we get this volume? We have to multiply this by the velocity, no? Area times the velocity, right? Because here is volume flow rate, right? The volume flow rate, which is also the V dot or Q. Now, in other words, they are Q. Q is AV, right? Q equals AV, not the heat, not this the flow rate. Flow rate, QAV, not the Q which is heat. No? So it is in the fluid dynamics. In fluid dynamics, area times velocity, meaning meter square times meter per minute or meter per second, no? Cubic meter per minute. Okay? So that is our point. So let me erase everything so that we can uh, we can uh, be more clear in this, right? So let us use this yellow now. So first we have to compute the flow rate that in this case, this one, right? So here. So this thing here is V equals area times velocity, which is area pi d square over 4, right? Then velocity is 366 meter per minute. Okay, so pi over 4 d. What is d? It was given that 183, right? Square then centimeter square. Okay, so pi over 483 square then centimeter square, right? And then that's the area. We will have an area, and then we will multiply with the velocity. So area then times velocity, which is what is this? 366, right? 366 meter per minute. Meter, is it meter or what? Meter. Where's that? Oh yeah, 366. 366 meter per minute. Sorry. Yeah, 366 per minute. So there's a problem here because meter and then minute, okay? We have to do something about this. So meter per minute, so this one, right? So we have to convert this into uh, meter. No? So let me put this pi over 483 square, then centimeter square. So here there is 100 centimeter for every 1 meter, right? So if you square this, so you can remove the square centimeter, and then this one is 100 square. Then this is square meter, right? So square meter already. Yeah. So here area times velocity. This will become square meter. The velocity is meter per minute. So our answer would be meter cube per minute. Yeah. So here, assuming that the calculation of this is correct, yeah. So this one is the velocity. No? So this one is the velocity. This one is the area. Area in meter. Yeah, in meter because of this. 100 centimeter, 1 meter, then you both square. Yeah. So you will have a kilogram per minute because the meter and meter will be cancelled, right? So square um, meter then times meter will become meter cube, right? Meter cube per meter cube there, right? Meter cube, and then meter cube will be cancelled. This one, yeah. So the meter cube here and the meter cube here will be cancelled. Then kilogram will go here in the numerator, and the other one is the minute, right? Here. So it becomes kilogram per minute. So this is the mass. So here is the mass of extracted, no? Ay, not yet. Mass of dry air. We're still in the dry air. So this is the dry air that is entering in point one, no? So here, no? So here there is a mass of dry air that is equivalent to 100 1137.9. Wala. So here there's dry air that is 1137, no? So 1137.9 kilogram per minute, right? So that is mass of air. So now, if that is the case, it's not yet complete. So our our intention, our solution is this, no? So the mass extracted, the amount of water extracted here is MA, then specific humidity 3 minus specific humidity 2, which is always also equal to SH1, no? So this one, 0.0396, then 0.009. No? So where's that? Here. So specific humidity 3. So specific humidity 3. So specific humidity 3 minus specific humidity 2, no? So or like this. W3 minus W2 times mass of air. So here, 1,137.9 kilogram per minute is the mass of air. Yeah? And then specific humidity at 3 is 0.0396. So here.
Yung tanong, continuous dryer supplied with air at 21 degrees Celsius dry bulb with 16 degrees wet bulb heated at 275 degrees C. It enters the heating coils at a velocity of 366 meters per minute and the size of the circular duct is 183 cm. The condition of the air leaving the dryer is 43 degrees Celsius, dry bulb and 70% relative humidity. The moisture content of the entering material is 24% and the moisture content leaving material is 8%. Calculate first amount of moisture evaporated 2 capacity of dryer, and 3 heat supplied to air. So, ito yung given. At point 1, 21 degrees dry bulb and 16 degrees wet bulb. Point 2, 75 degrees. Tapos sa point 3, yung ano na discharge na 43 degrees wet bulb, dry bulb, and 70% relative humidity. Tapos sa ano, psychrometric chart, kinuha ko na yung mga values na kailangan natin. So sa ano W1, yung ano, yung humidity rate ko, 0.1, 0.09 kilograms per kilograms of dry air. Tapos yung ano niya, specific volume, 0.846 cubic meters per kilogram of dry air. So yung enthalpy niya is 44.8 kilojoules per kilogram of dry air. Tapos sa point 2, syempre heating lang naman yan, sensible heating. Pareha sila ng ano, yung humidity ratio ng point 1. Tapos, nung nakuha ko na yung humidity ratio niya, nakuha ko na rin yung V2 niya, o yung specific volume, but yung H2. Tapos sa point 3 naman, given tayo ng 43 degrees dry bulb, tsaka 70% relative humidity. Nakuha na natin yung humidity ratio at point 3. Tapos yung ano daw, yung moisture percentage na feed is 24%. Tapos yung percentage ng moisture of the product is 8%. At sinabi rin yung ano, yung velocity daw ng dry air pumapasok is 366 meters per minute. Tapos yung ano natin, cross-sectional area natin is 183 cm in diameter. So sa 1 ton, amount of moisture evaporated. So yung formula for amount of moisture evaporated is mass of extracted water vapor is equal to the mass of dry air minus W3 o yung ano, humidity ratio at 0.3 minus humidity ratio at 0.2. Tapos, unknown tayo ng mass of dry air. So, solve natin yung mass of dry air. For ano, mass flow of dry air, meron tayong ano, na formula na mass of dry air is equal to ano, volume, flow rate, all over specific volume. Tapos yung volume flow rate natin, makuha natin yung gamit yung ito. Meron tayong diameter, meron tayong velocity, makakuha tayo ng volume ng ano, mass of dry air. So, yan lang, conversion lang, 366 multiplied by area. At as conversion lang ng cm to meters. Tapos, all over, specific volume at 0.2. 0.2. Hindi ko na sinama dyan, pero ito yung 0.2.
Okay.
Tapos, makakuha tayo ng mass of dry air na 1,137.9 kilograms per minute. Tapos, yung mass of extracted, makuha na natin 11739 kilograms per minute multiplied by this value, yung ano natin, yung humidity ratio at 0.3 at humidity ratio minus humidity ratio at 0.2. Tapos yung mass of extracted nga is 34.81 kilograms per minute. Ito na yung sagot. Tapos, number 2, capacity ng dryer. Ano lang naman to yung volume flow. Nakuha na natin yung kanina, mass of dryer multiplied mo lang sa ano, V at 0.2. Specific volume at 0.2. Tapos ito na yun, capacity is equals to 1,137.9 kilograms per minute multiplied by 1.001 cubic meters per kilogram. Tapos makuha na tayo ng volume or yung capacity ng dryer. Ano yan? Volume flow rate. Tapos yung heat supply, ano lang naman yan? Q is equals to mass of air multiplied by H1, ay H2 minus H1. Yan. H2 minus H1.
Ilan yung nakuha mo?
Ito, sir.
1,046.9?
Wait, sir. Mali pa to, sir. Mali pa.
Bakit
Naka-minute pa.
1,046.9?
Ano, sir? Dapat naka-seconds pa yan. Kaya lang, sir. Convert ko lang. Ayusin ko na, sir. O, okay na yan.
Balik ka muna sa una. Balik ka sa una. Sa number one. Balik ka sa number one, Glenn. I-convert mo
Ito,
muna
sir.
yan ng seconds, no? Kasi ang standard natin, di ba, pag sa time is second eh. 34.81 kilogram per minute. Divide mo ng 60 yan. Divide mo sa calculator. May calculator ka pa dyan?
Meron, sir.
34, sandali ah. 0.81 divided by 60. Mga 0.5, ano yan eh. Ano sabi mo? 0.58, 0.56, na mga ganun yun. Yung ano mo na, hindi, yung last na answer mo na, ito, yung huling
Ito
answer
yung,
mo na, yung
ito
last
po yung
na answer,
kailangan.
yung huling answer mo na, di ba? Pwede naman.
Ah, sige. Kailangan, sir. Kailangan din po kasi ito dun sa,
Sige,
solution.
sige, sa mas mauna, sige. 0.58 yata, no? Kasi 0.58 ang answer ko or 0.56. No? Kasi depende kung ilan yung mga decimal na ginagamit natin. Ha? Basta 0.58 or 0.56 siya dyan. Ilan din ako mo, Glenn?
Answer.
Ilan? 0.58.
0.58.
Okay, next. Yung number 2. Anong ginawa mo sa number 2?
Palitan na natin ito. Per seconds ko rin ito, sir.
Hindi, sige, iwan mo muna. Iwan mo na. Ako na bahala dyan. Sa number 3, ano yung anong formula mo? Di ba? Is a mass of air then ano yan? H2 minus H1?
Yes, sir.
Sige. Ano mo? Para kilowatts na lang, ha? Para kilojoule per second.
Ayan, sir. Tapos, ano lang natin, convert lang natin, ay, divide lang natin by 60. Tapos makuha na natin yung kilowatts.
So, tama ba yung kilowatts mo? Pakicheck mo yung figure. Mali pa rin. Sige. So, ilan yung heat sa dryer? Ilan?
Tama pala, sir.
Tama rin. 1,000. Ilan? 1,004. Ayan na? 1,046.
Yes, sir.
87. No? Okay. May problema lang. May concern lang ako doon sa number 2 mo. Number 2. No? Iba kasi yung pagka-solve ko dyan eh. No? Pakibitaw mo yung pakibitaw mo na yung presentation. Ano ko yung presentation ko, ha?
Ayan na, sir. Okay na, sir.
Okay na. Sige, ako muna, ha?
Tingnan lang, hindi pa na. So, ito yung tanong. 25 metric tons of desiccated coconut meat containing 40% moisture is to be dried at 10% final moisture in 24 hours. Atmospheric air is 26 degrees dry bulb and 40% relative humidity. It's first preheated to proper temperature before reaching the product. The air leaves the dryer at 29 degrees C, dew point temperature, and 90% relative humidity, neglecting the heat capacity of bone dry stock and the heat needed to heat the copra tracks. Calculate 1. The proper temperature into which the air to be preheated. Number 2. The production rate of metric ton per hour of copra. 3. Intake flow rate in cubic meters per second. Number 4, mass flow rate of steam required to be preheated. If steam is used for heating is 80 degrees dry bulb temperature with saturated condition. So sa number 1, ito yung tanong. The proper temperature into which the air to be preheated. So sa figure, mark na natin point 2. Ayun yung proper temperature to be preheated. So at point 1, meron tayong given na dry bulb temperature na 26 degrees RH na 40 na 40%. 40% lang yan. Tapos makakuha natin yung humidity ratio. Ito yung nakuha kong humidity ratio, 0.00.
Glenn, sandali, ano ba yan? Sinabi ba na adiabatic? Was it said that is it adiabatics, yung...
Ayun sir, neglect the heat capacity, bone dry stock, and heat added. So neglect the heat sir.
Oh, okay.
Adiabatic.
So, ibig sabihin walang heat added, walang heat na...
Saka hindi naman sinabing sir, walang ibang sinabi. Pag di sinabi, di ba sir, adiabatic.
Pag hindi kumbaga default yun. Sige.
Sir, default. So, ito yung natin, psychrometric chart natin. Since yung adiabatic siya, 0.1 to 0.2, sensible heating, yung W2 tsaka W1 is equals lang. So, makakuha na, at sa point 3 naman, sinabi yung dew point temperature na 29 degrees Celsius tapos yung relative humidity na 90% lang yan. 90%. Tapos yung H3 niya, nakuha natin at 96.8. Di ba dito sa na to? Sa pag-adiabatic, sinabi nga sir, wet bulb is constant or yung enthalpy is constant.
Enthalpy is constant.
No, sir. So, H2 is equals to H3. Tapos, meron na tayong W2 tsaka W3. Tapos, pag pinag-cross natin yan, o pag pinagana natin yan, cross natin, makakuha tayo ng point. Ayun yung point ng preheated air. So, yung at point na yun, makakuha tayo ng value na 74 degrees Celsius sa psychrometric chart. Ayun yung yung sa number 1, nakuha natin yung temperature. Tapos sa number 2, production rate of metric tons per hour of copra. So, ito yung formula. Bone dry mass ng product plus sa bone dry mass ng feed. Tapos i-arrange natin, may F sa, bali yung i-isolate natin yung product, ito yung magiging formula. Tapos sabi doon, yung F natin, which is yung feed, sabi, 25 metric tons of desiccated coconut meat containing 40% moisture to be dried to 10% final moisture in 24 hours. So meron kang 25 metric tons of desiccated coconut meat in 24 hours. So ito yun. 25 metric tons all over 24 hours.
Okay.
Tapos substitute lang yung value. Ito, 4%, 40%. Kasi nga, mass of feed, mas malaki yung percentage niya. Tapos yung mass ng product, percentage ng moisture ng product is 10% lang. So, nakuha natin yung value, ito, 0.694 metric ton per hour.
Okay. Very good.
Next, sa intake flow ng flow rate na in cubic meters per second. So, ito yung formula. Volume flow or intake flow equals to specific volume at 2 kasi sa point 2 yun. Ito yung dito may fan dito, di ba? Parang may dito yung intake ng air.
Kasi 2 and 3, di ba? Yung 2 and 3 is drying process, di ba? 2 and 3. Yung 1 and 2 is heater, mga coil yan. Sige.
So, yan. Ito yung formula. Volume flow rate, specific volume multiplied by mass of dryer. Ito yung unit niya. Cancel yung kilogram, kaya makakuha tayo ng cubic meters per second. Tapos, given naman yung V2 natin at point 2, since nakuha natin yung point dito, makakuha natin yung ibang point yung maganyang point, yung specific volume.
Specific volume, sa psychrometric chart. Okay. Makukuha mo yun, specific volume. Anong nakuha mong specific volume?
Ito sir,
0.997.
Tapos yung wet bulb natin, kailangan din natin which is 0.26. Nakuha rin naman natin. Ito. At point dito,
kasing linya siya ng enthalpy, di ba? Kasing linya siya ng enthalpy.
Ito sir. Okay, next. Yung mass of dry air. Ano yung formula niyan? Ito. Feed minus product all over W3 or humidity ratio 3 minus humidity ratio 2. Tapos yung humidity ratio 2 natin, nakuha natin kanina. Ito,
Pareho ng 1.
W, W2. Ito yun.
Pareho din ng 1, no?
Okay. So, ito yung W3 na kuha lang natin. Tapos, input lang natin yung values. So, meron tayong 25 metric tons into kilograms, 25,000 kilograms siya. All over 24 minus 694.4. Convert lang natin, inurong lang natin ng tatlo. Bali, magiging 694.4 kilograms per hour na siya. Tapos, divided by humidity ratio 3, 0.26 minus humidity ratio 2, 0.0084. So, yung mass of dry air natin, multiply natin 1 hour over 3,600 seconds. Makakuha tayo ng mass of dry air na 0.3834 kilograms per seconds. Tapos, yung volume na natin, substitute na lang natin yung value ng mass of dry air tsaka itong specific volume, 0.2. Makakuha tayo ng volume natin, 0.3822 cubic meters per second.
Volume flow rate yan ng air. Di ba?
Yes, sir.
Pumapasok. Volume flow rate kasi volume per time. No? Rate kasi. Flow rate eh. Oh.
Yes, sir.
Okay.
So, sa 3, sa 4 na, mass flow rate of steam required in the preheated if steam used for heating is 80% degrees dry and saturated condition. Ito yung yung diagram ko. So, ito yung pinasukan ng mass of air, tapos yung mass of steam. Ano lang naman yan, yung, ano ba to? Parang heat exchanger lang.
Heat exchanger na yan.
Ayan. So, dito, mass of steam lang, o yung Q ng steam, equals lang sa Q ng mass of dry air. So, ito yung formula. Expound pa natin yung QS tsaka QA. Formula ng QS natin is mass of steam multiplied by the latent heat, latent energy, or latent heat ng latent enthalpy at 80 degrees Celsius.
Okay.
Tapos, lang siya sa mass ng air, mass of dry air multiplied by the H2 minus H1. So, ito yun. Kuhain muna natin yung QA. QA equals to MA multiplied by H2 minus H1. Yung MA natin, yung mass of dry air nakuha na natin. Tapos, yung natin, H2 nakuha na natin yan. Makukuha natin yan. Kasi, di ba nga dito, pag nakuha mo na yung dalawang point, makukuha mo na lahat ng other values. Sa H1 naman, given na yung natin, RH tsaka yung dry bulb temperature, makukuha rin natin yung H dyan, yung enthalpy pag So, ito yung nakuha kong values. Para sa H2, meron tayong 6.8 kilojoules per kilogram. Tapos para sa H1 naman, 47.6 kilograms. Tapos solve lang natin, makuha tayo ng 18.88 kilowatts. So, yung naman, sa table ng steam table, yung H o yung latent enthalpy at 80 degrees Celsius, minus lang siya ng Hg minus Hf. Tapos yung is 2,308.7 kilojoules per kilogram. Tapos, from this formula, dito, Ms multiplied by HFG equals QA na. Tapos, i-arrange lang natin ito yung magiging itsura.
Ano yung pinagbasihan mo dito na temperature? 80, no? Saturated ba to pareho?
80? Yes, sir.
Oo. So,
saturated.
Gas tsaka fluid na makukuha mo, no? Saturated siya, di ba?
Opo.
Tapos Hg minus Hf para magkaroon ka ng mixture, HFG, no? Para yung latent siya na enthalpy.
Yes po. So, input lang natin yung value. Substitute lang natin 18.88 kilowatts divided by 2,308.07 kilojoules per kilogram. Tapos, pag nakuha natin yung values in per seconds, multiply natin convert natin in per kilogram per hour. Tapos makuha natin value is 29.45 kilograms per hour.
Na ayun yung mass of steam. Mass of steam
yes.
Yan.